Yes, sir.
Yeah, he had said that he will join. So Thomas, till then, can we just discuss if you have submitted the comments to the ethics committee?
Yes, sir. So we have submitted the MOU, the comments, as well as the addition of investigator. Date was today.
Okay.
So the meeting happens once a month. So we'll expect a reply by midday. So like,
Sorry.
uh, the meeting happens once every month, sir. So
Okay.
we can expect a reply by the mid of April.
Mid of April. Okay. Okay. And just wanted to confirm with you that we had requested increase in the sample size, right? So was that modified in the protocol? Because you had asked me if anything in the protocol needs to be changed or not. So that's why.
We have not made any changes to the protocol, sir.
But in the reply we have asked, right? In the reply we have said that we need more number of patient data.
But we have not specified a number, no, sir.
No, we have
Reply.
specified. Dr. Venkat, we had replied them with the number, right?
Yes.
Yeah.
1024.
1,000, yeah. We have said that, Thomas. And that's why I was a bit surprised as to why are you asking me if you want any protocol change, because there was a protocol change, which is the number of patients.
As a 1024, but
Yeah.
we had mentioned we'll work within the constraints of data availability. So you want me to make the change to 1000?
Yeah, we should mention, right? Because yes, we have
Okay.
said that we will work with the 1,024, but if I understand, you already have those many patients, right? Or are you telling me that you don't have those many patients? Do you have any idea on the number of
I'll check with,
patients? Sorry, I can't hear you.
sir.
Okay. So you have basically said that we
No,
require
sir, I do not have.
1,024,
I do
but
not
we
have.
will work within the. Sorry, you were saying something?
No, sir.
Yeah. So you have just if I understand correctly, you have said that we require 1,024 individual data, but we are willing to work within the constraints of what data is available, right? That's what you have said.
Yeah, that's a comment. Yeah.
Okay. Could you also check
So,
how many patients do you have?
okay.
Yeah, because that would have helped actually.
So as of now, do you want me to make the change in the protocol, sir? Or I'll get back with the actual numbers that is available and then.
Yeah, actually, you should do this, right? You should find how many number of patients you have available, and then we decide what you exactly change in the protocol, or else we are going in blind, right?
Yeah.
I thought you had already done it at your end.
No, sir. I'll just check with us.
Okay.
Yeah, but in any case, I hope what is submitted now is what we gave in the email, Dr. Thomas, that we gave. I don't know if you remember the last exchange was an email from me giving what needs to be changed. The and reply
So
to
that
the.
just reply to the comment. Yes.
Yes. So that is, I hope that is added to the report, because that is where we mentioned the number.
Okay. So what I thought was we would want 124 patients, but since because of data constraints, we'll be working with 100 patients. So anyway, I'll make the change in the protocol that we would need 124 patients.
No. What I'm saying is, with the reply that we have given, have you used that reply?
Reply, we have 124 patients, 1,024.
So you have used that what we have sent to you as a reply to the IEC, right? Hello, Thomas, you there? Hi, Thomas. Hi, Dr. Subhash.
Hi, Sukhit.
How are you?
All good, man.
Good. Okay, so actually, the meeting is for two things. One that we were just discussing with Thomas, and I think he will clarify soon. But the second thing was we wanted to discuss about the microenvironment before we go ahead with doing it. So, Dr. Venkat, you want to take it from here, or do you want me to quickly explain?
So maybe
I'll,
you could explain
yeah,
this
yeah,
better
I'll do
in
this. Yeah.
the medical.
So, Subhash, you have given us lymph node images, right? And the lymph node image are whole slide images. And in them, we have Reed-Sternberger cells. And everything other than the Reed-Sternberger cell is the microenvironment, correct? If I'm not mistaken. Subhash?
I can't hear the response.
Yeah. Subhash, you're muted.
I would assume so, Dr. Kshitij. I think that's what he has told in the past.
Yeah. So what we are planning to do is, even without deleting the
Everything else, everything else is micro environment. Sorry, somehow I was muted or something.
no worries,
So
no worries.
whatever are the background cells, you have the lymphocytes, you have the plasma cells, you have some histiocytes,
Right. My question is
proliferation depending
generally,
upon the type
yeah,
of Hodgkin's.
yeah. Generally, how do you label those that microenvironment? What do you like? You will be have you have some way of characterizing the microenvironment, right? Like neutrophil rich or plasma cell rich or something like that. What are the different categories you
Correct.
have?
So in Hodgkin's, the most common is the lymphocyte predominant one. The not most common. This is how they classify. That is the nodular sclerosis. There are types. So nodular sclerosis will have more of sclerosis and so more of spindle cells. The background will be more fibrotic. So that I will show you how it looks. Then there are types which are lymphocyte predominant, in which the microenvironment will be more of lymphoid cells, the lymphocytes.
Mm-hmm.
Others usually have a mixture of cells. The way we call it like a polymorphous background, in which the mixture is neutrophils, lymphocytes, plasma cells, eosinophils. So
Mm-hmm.
when we report when we are doing our general reporting, we
Mm-hmm.
usually don't classify all this in our report. We just say there's a polymorphous background. Whenever
Mm-hmm.
there's a lymphocyte predominant, we specify that because in the classification they are different. They may behave differently.
Okay.
So for us, the microenvironment is something which is in the backend. Identification of the RS cells is important, and depending upon the stroma, whether it's nodule, the tumor is forming nodules separated by bands, then it is like a nodular sclerosis type. So that all we report that way.
Okay, so to quickly summarize, suppose you take the entire lymph node whole slide image. The first thing that you
Hmm.
see is if there are Reed-Sternberger cells, right? To identify whether it is
Yeah.
Hodgkin's lymphoma, right?
So how I'll tell you how we go about. So normal lymph node will have a follicular pattern. In the sense, there will be a lymphoid follicles, big follicles. So how
Correct.
normal looks like.
Right.
So whether we see first at low power is that the lowest power, that is the scanner view, whether that pattern is still maintained or not maintained. And then we go ahead. If it is not maintained, then there is something abnormal. Then easiest way is if the background cells, the microenvironment is a mixture of all these cells, then it gives a clue that okay, there is a possibility of Hodgkin's in this, because this mixture of cells we usually don't see in other lymphomas. So
Okay.
easy to identify too many eosinophils, neutrophils, rather than identify this scattered one RS cells here and there.
Mm-hmm.
So once we see this microenvironment, that the microenvironment is little polymorphous of lymphocytes, plasma cells, eosinophils, then we start searching RS cells.
Mm-hmm.
Because they will be scattered. They may have some special organization. They may be sitting as a cluster in somewhere, or maybe diffusely scattered. So this is how we go about when do we do under the microscope. We look for the architecture, we look for this background, and then we look for RS. So RS actually is the third thing which we look that way.
Okay. Okay.
This is for Hodgkin's.
Okay. And
Yeah.
sorry, go on. Go on.
And there are ways if you want to pick up these microenvironment cells, like we did CD30 for your
RS cells. So similarly, there are certain IHCs, like we can do a like CD138, which will pick up only the plasma cells. Then there is one more marker called myeloperoxidase, which will highlight as the neutrophils. And the
Yeah, but we will not
eosinophils
get
have their
all of them, right? We will never get all of
correct,
them
correct,
for
correct.
so currently we will just get lymph node whole slide images, which will have
And
Reed-Sternberger cells identified. Reed-Sternberger cells definitely inside because all of them are Hodgkin's lymphoma patients, correct? And
yes,
then there will be this different types of microenvironments. Right. What we are trying
yes,
to, what we wanted to actually check with you, and Dr. Venkat and I, we were discussing this, is that we could actually at some higher degree of resolution, so that, so basically you have the whole slide image, right? And what we do is,
correct.
instead of taking the entire whole slide image, let's take representative patches inside the whole slide,
Patches.
right? So
Yep,
suppose you find
yep.
X, take N number of patches from each whole slide image. So
Okay.
from one patient, suppose for just for argument's sake, we take 10 patches and we
Mhm.
take them at a resolution so that the Reed-Sternberger cells really are not dominating them. Okay, we take patches
Okay.
such that the Reed-Sternberger cells are not dominating them. Okay,
Correct.
so now suppose you have 100 patients and you have 100 WSIs, but from each WSI you have 10 patches. So you have
Mm-hmm.
1000
Thousand.
uh,
Yeah.
uh, patches, correct?
Mm.
And then because we have taken those patches at a resolution where the Reed-Sternberger cells are not going to substantially skew our vision, um,
Mhm.
we do unsupervised clustering to see what are the different types of microenvironments there are in these 1000 images.
Correct.
So
Correct.
this is what we were thinking of doing, and we wanted to check with you before doing this is deleting the RS cells from this patches so direly important, or because we're doing it at a resolution where the RS cells are not going to muddy our vision, we can like, correct, Dr. Venkat,
So
this
we
is
can,
what we were discussing.
yeah.
Yeah, basically,
So
when Sitich says that we are taking at some resolution, basically we are talking about the magnification, right, Dr. Subhash?
yeah, understood.
Instead
Yeah,
of
yeah,
40x, we
yeah.
can have it 20x, let's say. Then
Correct.
my question comes, maybe if Hodgkin, we have the WSAs of the Hodgkin lymphoma, and we should assume that the microenvironment for all this is the same. Am I making a correct
Uh,
assumption?
more, not exactly same, but more or less we can say the degree may vary. Some may have more lymphocytes, some may have more EOs. That will
But
vary.
the
But
pattern
yeah,
will be
by
same.
and
The
large,
pattern is same.
you will have. So, like I said, some will, so the cases such as like lymphocyte predominant, those may not have your eosinophils and neutrophils very much, or maybe only very few or scattered.
No.
But
So
yes,
what Dr. Venkat was asking is, within a patient, within one patient, there will
uh,
be no different types of microenvironment. There'll be one type of microenvironment.
yeah, 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 yeah,
Yes.
yeah.
Yeah. That is
So
that
that's what.
right,
So
Dr.
we
Venkat?
can.
Sorry, I missed that part. Sorry, what?
So within one patient, suppose in one patient's one lymph node, you will not have 10 different types of microenvironments. You will have just one type of microenvironment.
Correct, correct.
Yeah.
Okay. So then,
So
Dr.
yes, so that will be there. So what I'm saying, yeah, when we go for patch level, it is it. See these cells. What I'm saying, eosinophils and plasma cells, and even the neutrophils, so they have a very characteristic. So if I show Kshitij 10 eosinophils, even he can pick up them. They are so characteristic. Same for
Okay.
plasma cells. So when we do eosinophils is very easy because it has that it's the only cell which has the orange cytoplasm. Rest all are pink and blue and other things. So they
Mm-hmm.
will be seeing you. Even for
Mm-hmm.
plasma cells, if I sit with you and show you, you'll be able to pick up. So when we keep a patch with the RS cells and with this background cells, no, it is not a
Mm-hmm.
problem. We will easily subcategorize each and every cell, and even we can develop label functions to identify depending upon their own characteristics. So some label function can be made for you.
Dr. Venkat, then instead of doing even that, right? Dr. Subhash, the idea was that we wanted to see first in an unsupervised way can we just categorize the patches into different kinds of uh, microenvironments? Because this is what Dr. Sridhar had said, right? Like you, as humans, as
Yes,
pathologists, we have certain restrictions that
correct,
we are trained to look at 4 or 5 types of microenvironments, but maybe
correct,
using image processing, we may be able to identify better categorization. That is what we were
correct.
discussing.
So yes, so that
So
is
that
what. So
is one,
these,
yeah.
yeah,
So one way to do it is what we just discussed. Another way, actually, Dr. Venkat, what Dr. Subhash is saying is we should also, which I think we should also do, is start with the hard start, warm start that we do with Akshit, right? We identify eosinophils also and lymphocytes also and plasma cells with Dr. Subhash and use shallow labeling functions to identify them. And we will be able to identify microenvironment the way the pathologists also do.
Correct.
yes,
Yes. Okay, that's not a problem. I mean, we can do it for a couple of patches.
yeah. Yes. So what we can do, maybe I'll set with some of you, and I can show you what exactly a using will look like and all.
Yeah, the
Some
way we
session we
did.
can
Yeah,
have.
yeah.
Yeah,
The
the
way
way
we
we did
did
for RS,
for
correct.
RS cells. Yeah, yeah,
RS. Yes.
yeah.
Similarly, we can have one session, and then I will show you how what we look, how we define any cell as plasma cell, lymphocyte, or whatever. And then you can use your brain to develop something, and then you can use those level functions that
Yeah. Dr. Uma has asked a question. Subhash, can you please check?
way.
I can read it out for you.
So she has said it is subtyping based on histology and then analyzing the microenvironment. So currently now we were EBV status, so that is Epstein-Barr virus.
Yeah, yeah. Epstein-Barr
So
virus. Yeah.
these Hodgkins have, yeah, so Hodgkins have those, they are driven by this Epstein-Barr virus. Right now, our
Hmm.
first thing is like we are categorizing the microenvironment, and then maybe from the EBV status we can make some correlation that way. We are right now subtyping only on the basis of histology. So what she means is we are not
Okay.
taking any IHC pattern right now. But Uma, we can do like whatever
Subhash,
like.
I have
Uh,
one query. Like when we say lymphocyte rich classical Hodgkin, so
uh,
the lymphocytes are all B lymphocytes, but
correct,
in mixed cellularity they are T lymphocytes. So then are we taking
correct.
into account that also or only just lymphocytes on morphology?
Right now it is only lymphocytes. So the
On
first thing is
morphology.
like
Yeah.
to segregate. Yeah, first thing is just segregating the different components in a WSI. Like R is the microenvironment and how it is the, like say the proportion of each of these, like lymphocyte rate or whatever. And then maybe in the next step we may go for this subcategorization of only those lymphocytes, how they are different and all. So right now, Uma, we are not doing that subcategorization, but once things get streamlined, then we can go for the next level.
Yeah, and also
Okay. So right
what
now you may be having most of them must be mixed cellularity then.
not
Yeah,
necessary, right?
so not so see, mixed cellularity are there, then NS variants are there. There are
Hmm.
there are some lymphocyte predominant one also. I'll have to check the list, but there is mixture and there will be variation in the cell line. That way. So right now we have shared I think 50 cases or 40 cases. I don't remember the exact number.
Yeah, yeah, yeah.
And
Okay.
let's
Because
see
and
how these results.
the EBV
E-
positive ones will have granulomas also. So
Correct.
I
So
mean
that will
all that.
also be picked up. Yeah. So that will something which is not fitting will also be picked up. That's something which we you me sir have to validate what these are. So if there are multiple such images coming up, then we'll have to label them. These are granuloma. So this is like a supervised training that okay, we label these as granuloma, and then it is feeded back in the algorithm. So next time
Yeah.
the
So
algorithm
first,
automatically
yeah,
picks up.
yeah,
So this is how we
yeah.
go about.
Yeah. First, actually, Dr. Uma, what we want to do is uh, we have a way to identify Reed-Sternberger cells, so that won't be a problem. Uh, then actually my discussion with Dr. Subhash and Dr. Sridhar was that the microenvironment is more important because it determines the tumor aggressivity and other characteristics of the tumor.
Correct.
Correct?
Correct.
So now, as pathologists, you identify lymphocyte rich or polymorphous type or fibrotic or nodular sclerosis type tumor.
Yeah.
Correct?
Yeah.
Uh,
Yes.
so there are two ways of doing these things, right? Either you tell us for all of them, what are these categories for every image that you send to us, you tell us whether it is lymphocyte rich, polymorphous, fibrotic, or nodular. But here comes the constraint, right? You will only look at four different categories, right? You will not potentially look at another fifth type of category or subcategories within a category, correct? So what we are planning to do is it's a very simple for us currently it is we think it is suppose you have 20 types of cats, right, of images, and you can do unsupervised clustering to identify what are these 20 types of cats, right? And the image algorithm will tell us that there are 20 types of cats. So this is the same thing that we are trying to do. So what I confirmed with Dr. Subhash just now is that if there is a lymph node of a patient that is been given to us, the image, the WSI, there is just one type of microenvironment. There are no multiple types of microenvironments. Like in the same lymph node, there is no fibrotic and lymphocyte rich, right? It's either fibrotic or lymphocyte rich. Correct?
Yes. Yes.
So what we will do is, because WSI images are huge to work with, we will take representative patches within those WSI images of one patient lymph node only. So for example, we take 10 patches from each WSI image of each patient. And if we have 100 patients, you will have 1,000 patients, 1,000 images, 1,000 patches. Okay. And then without telling the algorithm, we want three clusters, 4 clusters or anything, we'll just say, now just cluster them for us. Okay. Which is then driven by the computer vision algorithm, right? It is not driven by telling them that you will either find lymphocyte rich or you will find polymorphous or fibrotic. So we are just trying to see whether we can cluster them separately based on the patterns that the ML algorithms will identify. This is unsupervised, right? You are not telling.
Yeah.
You are not telling. And maybe it will end up being in 4 categories. And we could then come back to you to validate. Okay, just tell us whether this is lymphocyte rich or polymer. So this is what we want to do. Instead of you, and if you are able to validate 10, 15 from each, it decreases your work, right? You don't have to label all of them, and we are still able to identify the microenvironment, which is a feature that will go into our mega algorithm for prognosis.
Okay.
This is what we plan to do. Now, your question about Epstein-Barr virus, actually, I would have a counter question just to ask whether do you do it for everyone? If you don't
we do it for everybody.
Okay.
Yeah,
so
yeah,
then,
we do
yeah.
immunohistochemistry for every case.
Yeah, and then you already know whether it is Epstein-Barr virus positive or negative, right?
Yes.
So you don't need us to do
So
some
what
image
I'm asking
processing.
is, if we give you the subtype and EBV status also, would it help better?
It will be. So suppose the EBV status, right, what you're saying about, it will be a feature in our bigger algorithm to determine which treatment is working or not. So that will be a feature that will go into our bigger algorithm. This is what I'm trying to say. What I would also like to ask you in return is that, does knowing the EBV status affect my clustering for microenvironment?
Does knowing the, pardon me?
So suppose you tell me the EBV status, right? Like there is a whether it is EBV positive or negative, which you already know, right? It's a yes or no problem, right?
Yes.
It is EBV positive or it is EBV negative, which you already know. You don't require us to do any image processing to tell us that. Correct?
Yeah. Yeah.
My question to you back is, if you tell us this EBV status, does our clustering process change? Does knowing the EBV status give us additional information for some clustering constraints to put in? If
No,
not,
no.
yeah,
I don't
if
think so.
not, then it doesn't matter, right? It will be a different feature for us into our bigger algorithm. So the bigger algorithm is
Okay.
actually, we take informations from the WSI. So from the WSI, we will get the following information, just to tell you. One is we'll identify how many Reed-Sternberger cells are there. And second, we will identify whether they are clumped together. Is there some spatial pattern to it? Okay. These are two features that we extract from the WSI. The third feature is what kind of microenvironment is there. These are the three features that we'll identify through image processing. The fourth feature that you will provide us is whether it is an Epstein-Barr virus positive, negative lymph condition. Okay, so from the
Got it.
WSI, we have four features that we have identified. Similarly, with Dr. Ashish, and we are identifying what are the what is the tumor load, where is the tumor, what is the tumor volume. These are the features that we extract from the PET scan. Okay, so for example, we have four features from PET scan, four features from the WSI images. Correct? The next thing to do would be we go to your electronic health records and identify what are the other features that you generally collect, right? Like what is the comorbidities, was there a family history? These become additional features. All of these will go, for example, in a deep neural network model, which will tell us, and also it will tell you whether for example, after the ABVD treatment, you have another PET scan that is done after 2 cycles, correct?
Yeah. Yeah.
And at the end of 2 cycles, you will see whether the treatment has worked or not. Correct?
Yes.
What we are trying to just see is that suppose if you have done ABVD treatment, what are the features that will be associated with success of ABVD treatment and failure of ABVD treatment?
Okay.
Okay, this is the final goal. Whether can we identify even before starting ABVD, there is success, what is the chance of success of this? What are the features that are associated with success is what we are trying to do.
Yeah. Yeah. I got
So
it.
from the WSI, we will ultimately pick up what are the cases which are EBV and what is the maybe a viral quantification also. Like that will be done at a later stage. Like similar algorithms are there for HPV in the head and neck cancers, and some people have also worked on it. So depending upon the tumor, they even tell us the threshold that the HPV is less than 10, more than 10. So similarly, we'll also work and reach to that level that we can identify EBV presence, absence, and what is the. So that is also possible.
Okay. Okay.
Okay.
So
And
today's
the lymphocyte depleted ones are not included in this, no?
Subhash, actually the question is for you.
Currently, I think we had very few of those. But see, the as the batches will go to KCDH team, they will have cases of lymphocyte depleted also. So we have a big list of say 400, 300 to 400 cases. Right now, we have just given I think 40 or 50. So ultimately, we will have some more cases, and then we will check. So they will also, because they are not that common. So
Right.
the cases are less of those. So ultimately, they will reach KCDH, even the depleted ones.
Yeah.
Okay.
Understand.
Okay.
Understand.
Thank you.
Yeah. So, Dr. Subhash, this was a question actually, which we thought we will ask you before we do it. which you have answered. So we will then go ahead and
Yeah,
do those stuff.
yes. Actually, I lost the connection of someone. I was not able to join in again. So just join back. So yes, we do an kind of unsupervised. Me and Uma will do the validation also. I will show you how it looks like. So it will be easy for you to pick up by yourself itself.
Yeah, what we will do is we will do it both ways, Dr. Venkat. We will do it unsupervised way, and we'll also do a supervised way by a warm start that Akshit is doing, and we'll see what is the concurrence between both these methods, right?
Absolutely. Yes.
Yeah, that
And
way.
obviously, there'll be some overlap. For that, we will do the validation part also. Like there'll be overlap also.
Correct,
Not putting
correct.
in this, not putting in that me and Uma or Uma can do the validation part.
Sure, sure. Makes sense. Makes sense. Yeah. So these
So
were
the
the
good
two
thing is
doubts.
like now so what I wanted to suggest, like once we develop something, like if the algorithm picks up eosinophils by itself,
Mhm.
so the same model can be applied elsewhere. Like say in the colon, gastrointestinal tract, there is could pick up eosinophilic colitis, eosinophilic gastritis, and then we can do the quantification part. So once we have a robust model of
Mhm.
self-identification of this can be applied in other places also.
Correct, correct.
That way. So
Yeah.
that should how we should work upon. So it should give us the number quantification. So that
You
all
also want the number now? Not right now, right?
not right now, but that it should give because see in colon the gastritis, colitis is all based on the number. In one field there were 20, 30 eosinophils, in one field there were 60 eosinophils. So
Okay.
for the later stage we will need that, but that is not a problem. I think that can be done easily.
Yeah, that I think we can do it if we zoom in to a level of the size of the cell. Then by giving some warm start, we should be able to identify which cells they are.
Yes.
Right, Dr. Venkat?
Yes.
What do you think?
Yes, yes. So I'm just thinking how we'll annotate. I think one annotation that they do is on path ML. There is one software that I think we agreed upon, right?
Yeah, actually, Akshit and we once sat with Subhash to do that. So we have done it once.
Yes, we have done that once. Automation we use our two parts, whatever is comfortable. Either way. So
Yeah.
Akshit was there. Satish and Akshit both were there last time we did that.
Yeah, we did it for the RS cells. Then we can also do it for eosinophils, lymphocytes, and something like that.
Yes. Yes.
Okay. Yeah. So these were our questions. Yeah. Thank you.
Yeah.
And Thomas,
Thank you.
you have.
Sorry, I couldn't speak much, but so summarily, are you saying
Professor Ganesh, you are mute.
so? Are we saying that we'll apply both a fully supervised approach as well as labeling function based semi-supervised approach, um, and we'll also uh, have the subtyping based on histology for my analyzing the microenvironment. So that subtyping would be the supervision, right?
First would be the clustering, unsupervised clustering based approach for the microenvironment. That will be the first thing to do. And then the labeling function based annotation would be that Subhash will give us a few examples of lymphocytes and eosinophils and basophils, for example, which then can be used with labeling functions to then label others. Yeah, these are the two things that we are thinking of right now.
Right. Okay.
Yeah.
So that basophils, eosinophils is the subtyping we are talking about, and that will be through labeling functions.
Yes, that will be through labeling functions because at some point, Dr. Subhash also wants them to be counted, and then counting it cannot be done manually. So we will have certain examples of, for example, basophils that Dr. Subhash or eosinophils that Dr. Subhash will give us. And then we will use them to train some shallow ML models or use heuristics based labeling functions and then identify similar others. This is what we plan to do. Yeah.
Yes.
Okay. Thank you.
Thank you all.
Yeah, Thomas, before you go, could you just confirm that you understood that the reply that we sent was the reply that was ultimately sent to the IEC? Could you confirm that?
Yes, sir, that was the reply that I sent, but
Okay.
we have not made the respective change in the protocol.
Yeah, which you will have to. Yeah. Okay.
Yeah.
Okay.
Okay.
Thank you.
Thank you all.
Thank you. Bye.
What about the discussion with